a laser beam strikes on point A of a half-sphere made of glass with index of refraction n equals 1.5. The center point C for the circle is at exact midpoint of the bottom line. The radius of the half-sphere is 10 cm. The distance from the striking point A to point D is 7 cm. Angle ADC equals 90 degrees. If the incident angle θ1 on point A is 17 degrees, what is the angle θ4 when emerging from point B? θ4 is the angle between exiting beam and the normal line. So center, here's C is center. This bottom line, C is at midpoint of the bottom line, this center. So AC is radius R. R equal 10 cm. Now, the index of this material is glass is n equals 1.5. Outside is air, and air is 1. So θ1 is incident angle, θ1. And θ4 is refraction angle at this surface, at point B. So we want to find what is θ4. And CB is normal line. AC is normal line, this normal line, AC, and CB is normal line. And R is radius. To solve this problem, we redraw this diagram as follows. Here's an air equals 1, n is 1.5 is the glass material. And θ1 is incident angle θ1. So we draw a line CE. The distance between C and E is D. We label this distance as D. D. And we label this angle is θ6. And this angle we label at θ2. And this angle we label at θ3. So this angle is θ3. θ3. And this angle we label as y. Because at this point E, this angle also y, because law of reflection, this y and this y, both are y. Now, consider consider the triangle ADC. For triangle ADC, we have, for triangle ADC, we have A divided by R equal cosine theta 6. So ADC, so A divided by R, this is the radius R, AC is radius R, so A divided by R equal cosine theta 6, and this is 90 degrees. Therefore, we have theta 6 equal cosine inverse A divided by R. So on point A, this point A, at this point, we use Snell's law. From Snell's law, we have 1 time sine theta 1 equal n time sine theta 2. Therefore, theta 2 equal sine inverse sine theta 1 divided by n. For triangle ADE, A, D, and E, this triangle ADE, we have this angle Y equal 19 degrees minus C2 and C6. So for triangle ADE, we have Y, angle Y equal 19 degrees minus theta 2 minus theta 6. Now, we label at point E, we draw a diagram. We draw a vertical line. This is normal line. We label this angle as angle X. So this angle is angle X. So angle X equal to 19 degrees minus Y. So right now on the left I have the formulas. Let's evaluate the values. From this formula, theta 6 equal cosine inverse A divided by R equal cosine inverse A equals what? So the distance from striking point A to point D, from A to point D equals 7 centimeter. So A equals 7 centimeter. 7 centimeter. The radius is 10. So radius 10. So I have this one. I have the angle for theta 6 equal equal 45 degree. Now theta 6 and theta 2 equal sine inverse sine theta 1 divided by n sine inverse sine theta 1 equal theta 1 equal to 17 degrees. 17 degrees. So theta 1 equals 17 degrees. N equal to 1.5. So sine 17 degree divided by 1.5 and sine inverse theta 2 equal 11 . degree. 24 degree. So I have theta 2. Now, this y angle y equal 19 degrees minus theta 2 minus 66. So 19 degrees minus theta 2, 11.24 minus theta 6, 45.57 degree equal okay 19 degrees minus 11.24 minus 45.57, so equal 33. .19 degree. Now, therefore, the angle x equal 19 degrees minus y equal 19 degrees minus y equal 33.19 equal 56 degree. 56.81 degree. Now, we have the angle x. We find angle x already equal to 56.81 degree. Now, at this point, what happens here? We need to calculate the critical angle at this point. So the critical angle we can calculate as follows. So the critical angle theta c equal sine inverse 1 over n equal sine inverse 1 divided by 1.5 equal 41.81 degree. Now, the angle x is greater than critical angle, so the angle x is greater than critical angle, so at this point E, our light will be totally reflected inside. So total internal reflection happens at this point. So there's no light coming out here. At point E, total internal reflection happens. Now, we need to find theta 4. Next step, we need to find theta 4. Consider triangle. For triangle ACE. ACE. Consider triangle ACE. We apply law of sines. We apply law of sine. We have d over sine theta 2 equal r divided by sine y. So d divided by sine 2 equal this radius r divided by sine y. This sine y. Now we apply another triangle. For triangle CBE. For triangle CBE, C, B, and E. C, B, E. This triangle, we apply law of Snell's law of sine. Law of sine. Law of sine, we have the following. D divided by sine theta 3 equal r divided by sine 180 degrees minus y. Okay, what happens here? D divided by sine theta 3, this one, equal to r, this radius r, divided by sine this angle. This angle. And this angle is 180 degrees minus y. This angle is y, so this angle is 180 degrees minus y. So I have here r divided by sine 180 degrees minus y. But because by trigonometry r here sine 180 minus y equal to sine y. Sine y. Sine y. Now, this I call equation 1. This I call equation 2. So r divided by sine y, r divided by sine y. So therefore, on the left term equal to of equation 1 equal to left term of equation 2. So therefore, I have d divided by sine theta 2 equal d divided by sine theta 3, because this term equal to this term because right term they are equal. Right term both r divided by sine y, r divided by sine y. So left term d over sine 2 equal d over sine theta 3. Therefore, d the same. So therefore, sine theta 2 equal sine theta 3. Therefore, theta 2 equal theta 3. Then apply Snell's law at point B. We have n sine theta 3 equal 1 time sine theta 4. And since theta 2 equal theta 3, therefore theta 4 equal theta 1. Therefore, theta 4 and theta 1 equals 17 degrees here. Therefore, theta 4 equals 17 degrees here. This is the answer.